is irrespective of your background, be it be of a mechanical background or AAA background or ECE background or civil engineering background, how AI will help you to boost your business, right? So my name is Anudeep, and you can find my LinkedIn there. You can connect with me. And as Sabi had already introduced me, I have 5 years of experience in dealing with the data, to put it simply. So the agenda of this session, what I thought would be, I would start asking you guys what exactly that you wanted to take away from this session, right? See, I have PPT done for you guys. I can simply go through it and go, but that wouldn't satisfy me. What would make me happy is to convey what is that you wanted. So if anyone wants certain topics to be touched upon, or if you have any questions, or generic questions coming to artificial intelligence, or it can be questions like what are the skills I should have to get into this field, such type of questions. If you have any generic questions that you want me to touch upon and take you through, it would be great if you could speak up now, or give it in the chat box, so that it would be easy for me to touch upon those topics. Because I would really don't want to make it as a speaking session for me, or else a communication practice session for me. It's like I wanted to help. I want you to take something out of the session. That is the whole intention that I have. So guys, any from the attendees, anything that you want me to specifically cover?
So anyone from the participants? Ikram, can you kindly change your microphone, please?
So, am I audible?
Yes.
So, hello, my name is Amar Mohanna. I would like to maybe discuss or talk more about the possibility of the implementation of AI using like a personal application in order to enhance our knowledge set that is being learned by maybe deep learning AI courses or even other courses. This may be an interesting topic to be discussed among practitioners of AI because there's some difficulty in
implementation part. Am I correct, Amar? Are you trying to convey?
Exactly.
Yeah. So yes, Amar, I have it in the pipeline. I'll make sure that I spend some time on that. Thanks for the inputs. Anything else, Amar?
No, for me, this is it. I think this might be the main concern of most of the practitioners that are learning and practicing AI.
I get it. I completely get it. So
because it's very easy to learn AI as an academical thing, because courses are out there, everything is out there. It's easy to do. It's easy to learn anything you could imagine knowing, but applicating this knowledge set into the real life projects and then encountering the problems that are behind this might be a difficulty for most people.
I can relate it. Yes, I would not only touch it, I would also give you some sources where you can actually see through different applications. Okay. So like, towards give me some time to, introduce the topic and talk about data, the data sources and stuff. And finally, I would get to the implementation part, Amar.
Yeah, sure. No problem.
Yeah. Thank you. So others guys, any inputs like how Amar had given? I can see Ikram giving in the chat that a discussion about how career for AI in AI for the fresh graduates. Yeah, I am definitely touching that part, Ikram, for sure. What else, guys?
One from Alishba too, a little of AI for final year students.
Sorry, Sabi, come again. For final year students, what is it?
There is one more message in chat. I guess it's private. Alishba said a little bit basics of AI for final year students.
Yeah, I am touching it. I am touching every part of the basics. So I won't be going deep, guys. I'll be leaving you with the basics parts for sure. No doubt about that. And as you know, uh, we'll be also touching the implementation part. Anything else, guys? Anything else before we get into the session? I just want to make sure that I am, useful to each and every one of you. That's my whole point of, having some time here, spending some time on this slide. So I would talk about the agenda. To talk about the agenda, I would talk about data, how data is being generated very aggressively these days. One thing. The second thing, the science of handling the data. It's pretty huge. I tell you, this science converges physics, mathematics, statistics, economics, and almost cutting all through the all the sciences that are there basically. How does it do? I would explain to you in a theoretical aspect, and I just wanted to show you certain applications of artificial intelligence in business and in daily life. Okay, so once I am done with this, we'll go ahead and see one implementation in a Jupyter notebook, and I'll share with you something called Kaggle.com. You guys know what is Kaggle? Must be knowing it.
Yeah, sure.
Yeah, I know it.
Yeah. Yeah, so Kaggle is very famous, where you can find different people. I mean, there are competitions that happen. There are also researchers and also academicians who come up and try solving data problems. So that is one good side. If you want, we can take up one notebook and we can also go through if you are patient enough. But yeah, I kept that to last. Okay, so. Primarily, I just wanted to make myself clear to everyone that I will be going through basics at first. So if anyone is having all the knowledge about this, please bear with me. And if I miss anything, any point, or if you have a better point, please convey in the chat or on the voice. Let's make it a kind of a discussion. Yeah, I don't want to make you guys sleep in the evening. Okay, so yes, coming to the topic. Data, the raw gold. Why I say data is a raw gold? Because the raw gold is found in the ground. Okay, it is coming up. It comes up with lots of messy things around, like mud and all that stuff. Now, how it is made? It is cleaned first, then it is boiled. It is boiled to certain temperature and then extracted. Okay, so this much is to be done for you to derive some insights out of the data. Okay, now how does insights help? This question might pop up on your mind. Insights help us to take a better decision, right? So for example, let's say we are planning to go to US. Okay, all of us are planning to go to US. Now, how much money should we ready? How much money should we make sure that we have? How do you take an informed decision on this, guys? Can someone come up and say? Should I vaguely say, okay, I'll have some 5 lakhs with me, that should be enough? Or will you be going to the Google? You'll go to Google and type how much it takes from Lahore to US. Okay, it takes, let's say, 1 lakh. I'm telling vaguely, guys. So, okay, it takes 1 lakh. And for me to spend around in the city, let's say we are all going to Las Vegas to enjoy. And say we are spending around 2-3 lakhs. So, how much currency conversions we have to do, and we have to understand how much spending we would be doing. We have to do certain estimations. Am I correct, guys? We do certain estimations and then we arrive at a decision that so and so amount of money should be in our hand to go on a trip to US, right? So how did we make a decision? We have taken an informed decision. So for businesses to take such informed decisions, we need to mine this raw gold, which is the data. Okay, so let's talk about data once. Google processes about 20 petabytes of a data. Go and search what is petabyte in Google. You'll understand how big is that number. And trust me, this is the data in 2008. This particular fact was taken out in 2008. Imagine with the advent of smartphones, okay, with the advent of smartphones, imagine how much more data are they getting, be it be the location data, be it be the search data. Today everyone has a smartphone, isn't it, guys? Now imagine the population of China is very huge, okay. Imagine the population of India, it is very huge. Imagine the population in Europe, America, Pakistan, Bangladesh, and all the countries across. Imagine how many smartphones people are using based on Android and how much Google is having, right? So they have huge and huge amounts of data. And Facebook, I hope all of us are using Facebook. So Facebook has 60 TB of daily logs, general daily logs. And imagine how many people.
Anudeep, I can't hear you. Can the participants hear Anudeep?
Those are we will
No,
come.
we can't.
I guess there's a connection problem, so let's wait a few minutes.
Hello, am I audible, guys?
Yeah, now you're audible.
I'm sorry, I lost power at my place. Let me just present my screen again. Where
Yeah,
did I
sure.
lose my power? I was talking about data, that's it, right?
Yeah, last slide.
This previous one? This one?
No, one more behind. Yeah, this one.
Here?
Yeah.
Acha, you guys did not, I was out of power when I was talking about this slide?
We get most of the part of this slide.
Okay. So basically what I'm trying to establish is the significance of data, guys. So let's talk about the science of handling the data. Let's talk about the complexity that we have around handling the data, right? So sources of data, if you ask me, are of two kinds of sources, guys. One is the primary data and the other one is the secondary data. Now, how do we get data? Is by taking the survey, right? So you might have seen Google Forms, right? Google Forms are to take a survey and understand how the opinions of people are, like that. Directly, we are directly contacting our primary sources of data, which means the people. In the example given in this slide, we are surveying the employees within our organization, which means we are directly taking data from the primary sources, right? Or else external data can be something like interviewing thought leaders in your industry. So taking opinions from different thought leaders, we can tell it as a external data. Likewise, secondary data. Secondary data, as in we have already data that was taken, and certain statistical aspects might be used upon that data to derive certain other columns or features, which we call features, right? So using that, we can, using that data, we can further go ahead and process the data. So such type of data sources are called secondary data. I'll explain in further. So this is like a you will have to match it carefully. So if you look at the kinds of examples that we have, if you see your websites reviews and marketing campaigns, etc., those are quite unstructured data, isn't it, guys? Those are in the form of text and in the form of rating from on a scale of 5. Okay. So it might be unstructured like that, or we can have structured ways of getting the data, like survey, such kind of data we might be having, right? Also, we have something called weather data. So weather data is always structured, isn't it, guys? You'll always get it in a degrees Celsius or degrees Fahrenheit. How is that? Because we have certain scale for that. We have certain standardization there in place, right? So such type of structured data are there, and also we have text data, and we have data from social media. We have data from in the form of voice recordings. So how many of you? I mean, how many of you must have heard it when you have called the customer care centers, right? So they must have told you that we are recording your call for the purpose of training and quality improvement. So when imagine if you have called a big business who is having some 1 million customers, okay, some 1 lakh customers. So when there are 1 lakh customers, how many calls will you record every day, and how many will you process? So if you appoint one guy to hear all the calls, it will take some years for him to process that data, isn't it, guys? So here is where our data engineering comes in place, which processes our data and makes it ready to fetch it for the data scientist to use it in certain way, so as to get insights from that. So what is the takeaway from these two slides is that you need to understand there are two kinds of data. One is a structured data and the other one is an unstructured data. Now, coming to the data collection part. Now, how do we collect the data? Data collection is of different types and different domains, guys. As I said, in terms of weather, it is a standardized collection of data. You always get for a so-and-so day, for today, the maximum temperature is this much. The minimum temperature is this much, is a primary data. What is the secondary data that you can get from this data? You can do an average, you can get an average of this minimum and maximum, and you can take out that secondary data and process it, right? So that is one way, okay? And if you look at your left side image, right, in a manufacturing industry, right, there are sensors. These this Wi-Fi kind of stuff that you see is nothing but the sensors, guys. So these sensors take up the data and store it in a certain memory, memory storage. It can be cloud, or it can be internal storage devices like that. Okay. So you must have heard on something called Internet of Things, as in you must have heard about the smart homes, right? So apart from smartphones, you have smart aspects like Amazon. Amazon has Amazon Lights and Amazon Alexa. You must have heard about Alexa, where you converse with a device and it does the action for you, right, guys? All of you, yeah. So we have data for all types of data. We are trying. If we comment on a public post on Facebook, do you think it's private? No, it is available for me to take up the data and do a sentiment analysis. For example, Twitter, right? In Twitter, if your tweets are public, using an API, I can take up the Twitter data and use it for the sentiment analysis, how people are feeling. Let's say, for example, US elections are happening. I can, based on the tweets that are public, I can take out the data and understand the sentiment analysis on Donald Trump, right? So how the Republican Party is faring in the elections. So such kind of data collection you can do using Internet of Things. Just to show you, we have smart logistics. We have I mean, if you see nowadays, for a bus travel from one city to the other city, they are providing tracking. How they are providing tracking? They are integrating the Google Maps, and using the location data, we can track our travel. Likewise, logistics in the sense when we are moving, suppose say we have given our all of our household goods for packing and moving, guys. We are moving to other city. In such a situation, if we want to track it, we can track it using smart logistics applications, right? And there is smart parking. So in high-end luxury cars, they come like this. When there is any object in the vicinity of the car, it starts throwing the sound inside the car that you are going to hit something. So that is under smart parking. And smart water management, I don't know how many of you do this, but when I was in childhood, twice or thrice I left the tap open without knowing. I don't know, like, yeah. So such things. So you need smart stuff. And by the way, I have done my BTech in Tripoli, guys. So when I was going through this chapter called sustainability, in the sense, see, generally you get electricity from coal or water. Am I correct? So when these two are natural resources which are depleting, so wind energy and the solar energy are the ones which are sustainable, isn't it? So when I was going through that chapter, the professor told one good thing which I can't forget, right? So when we are making smart sustainable products like windmill, so your windmill aspect, the wing of the windmill should be of certain height. The dimension should be defined in such a way based on the geographical part in which we are installing, guys. So all these are statistical calculations that you need to do. Okay. So all these involve statistics, involve data about the geography, about the way wind is flowing, the weather data, all these stuff. So there's a lot of data science that is involved in installing a windmill in a certain area, right? So such smart sustainability applications, we use sensors to collect the data and utilize it further to give us an output. Okay. So smart retailing, smart agriculture, again, the smart cities. So all these, okay, someone is saying that they have done a smart water management system. Really, really great. I really appreciate, because we need to conserve all the natural resources, because as we go some 10 years, we are unsure whether we all will have water to drink or not. Okay. So yes, all this is necessary. So that's how, using the sensors, the sensor technology is done by ECE, guys. Okay. We at the other end, the data scientist and everyone, we are trying to extract that data and understand how well it is working, right? So we need a combination of both the domain knowledge and also the data knowledge on how to access the data and process it. So I'll talk more about it in little later. So coming to how things work end to end, I wanted to just make it clear, guys. So as I said, we have, through the Internet of Things, we have sensors, we have certain aspects like surveys. I can do surveys, or I can have measuring devices which will give me the data. Okay. So I can store the data either in the cloud or in the physically, I can have servers and store the data. So once I have the data, the rest of the story is with the data engineers, data scientists and stuff, who take up this data and try to build the insights for the business. It can be for the business or for the government or for the, generic purpose. But our main aspect is to arrive at the insights part. Okay. Now, coming to artificial intelligence, is it a hype or a reality? Artificial intelligence can be used in every field that you can name. By now, you must have understood how it is used in the every field. We can, wherever the data is getting generated, we can use AI there. That's simple. Okay. But it sounds simple, but the way we perform operations on that is little difficult. Okay. So let me talk about higher education. Like not even higher education, even in the primary schools, here I can see smart schools that have come up, guys, wherein, each child's performance is up, each child's performance are being taken care, which means there's an AI application that monitors the performance of the child. And internet, needless to say, your Facebook app, your Instagram app, your WhatsApp, all these use AI at a very, very high level. And development tools. I don't know how many of you heard this news. We have seen Facebook had developed an AI which will do the coding by itself. It will translate the coding from one language to another. I forgot the name, but did you guys hear this news, guys? That it translates, this AI translates the code from one one programming language to the another programming language.
Yeah, I guess GitHub is using the repositories to train a model which can do this. So we are actually providing them with the data to actually do that.
I'm sorry, my bad. Voice was cut. What were you saying? Sorry.
I was saying that GitHub is actually training a model using the repositories that we put there. So they are actually using our code to make a new model which can take up our place.
Correct. Yes, Ikram, you're right. Transcoder AI by Facebook. Yes, it's also there. So you must have heard about these names. So data engineers, data scientists, data analysts, platform administrators. What do they do? You might have got the doubt. Yes. How many of you are having this doubt? What do they exactly these guys do, man? So many names: data scientists, data analysts, data engineers. What do they do? How many of you are having the doubt? Okay, data engineer. So what does a data engineer do, guys? Any idea? Very good. ETL. To put it simply, yes, ETL. So what is the purpose of a data analyst?
Data analysts find trends in data.
Correct. Well, on the yeah, you're right. Yes, I'm just let me just go through these parts very quickly to try the insights. Very correct. So data engineers, as someone rightly said, they do ETL part. ETL in the sense they extract the data from the sources. So let me come back on the slides so that I can explain it even better way. If you see this, right? So from the sensors, I have the data, right? So once I have the data extracted from the sources, I'll extract the data, the raw data, transform it the way the business is required, right? So I have to show the data in charts. Then I will transform it in certain way. Or else I have to give the data to a data scientist so that that guy will work on the data and give insights. Then I have to transform the data in certain way and load it. Load it in the sense, again, to come back on the same point, my loading depends on my application. So if I wanted to report the data, I load it into the reports. So if I want to give it to a particular data scientist, I can give him in an Excel file or whatever the way the organization had strategized on how to do. Okay. So this is what our data engineers do. Now, your data analysts and data scientists, what do they do is that your data analysts do some preliminary analysis in the sense, they try to present you what is already there. What is the data trying to communicate is what they try to tell. Okay. While the data scientists, they try to give you what would happen in the future. That's what your data scientists do. Coming to the platform administrators. So when we are trying to talk about data, guys, security is the point that comes up, right? So can everyone in the organization have access to the data of the organization, guys?
No, there are some limited access to the data.
Yes. So, so each country has its own data rules, guys. So the famous one, I work for an Europe client, so I'm talking about that. There's something called GDPR. Okay. So there's a regularizations that are there. Okay. Not everyone can have an access to the data. So it is restricted. So it is restricted, and your platform administrators will take care of who should have the data access. Like in a development environment, even the freshers can have. But if you go to your production environment, only seniors will have the access. If you observe in your companies or if you're working, if you observe, this is how it should be, right? So your platform administrators try to take care about the security. And I would say nowadays people are hiring a team of cyber security team, because nowadays attacks have increased on the companies, and people are asking actually cryptocurrency payments and stuff. You must have heard the news, guys. Yeah. So what is business intelligence? Business intelligence is basically all about, we have data, we sort the data, then we arrange that data, and then we present it visually. This is how your business intelligence works. So once we have presented visually, what we can do, guys? Any idea? Like, why are we presenting it visually? What is the use of reporting, guys?
For decision making, for high level organization. For the managerial
Come again. Further,
I'm saying
yeah, exactly. For the managerial level, to understand how how performance is happening. I can give that example, right? So it only talks about, let me come back to this slide a little later. Oh, where is my other slide? Okay. So your business intelligence is all about trying to communicate what is there in the given data. Am I correct? It can only talk about the data. It can only talk about the data which is already there. But coming to data science, it can communicate what can happen in the future. That is what your data science is all about. Am I correct, people? Yes? No?
Yes. Yeah.
yes, you are correct. It's for data science. It's majorly used for prediction.
Talking about the prediction. Yeah. So Subhan is saying ML engineer is missing. Yeah, see, data scientist or ML engineer, at the end of the day, what happens with data scientist is that he is more responsible, but your ML engineer is the one who helps a data scientist, if you ask me, okay? Then, it highly depends on the organization, Subhan. In the sense, some organizations hire a data scientist and tell him to do everything, including the data engineering. Okay, some organizations will have their own data engineer in place, data scientist in place, a statistician in place. Okay, so it depends from organization to organization. While coming to ML engineer, they want an engineer who will specially work on ML only. So that guy will be implementing ML models on top of the data, nothing else he would do. So that is ML engineer. Okay. Coming back to data science, guys, data science is like an ocean. Okay. And as I said, data engineering. So when you have a raw data and you are working on a certain kind of domain, let me give an example. Okay. Which example should I give? Other than IT, let me give an example other than IT. Okay. So if mine is a manufacturing industry, okay, let me say I am making something called PCB boards. Okay. If I have a PCB board, there is something called soldering that is involved in it. Can everyone understand what is soldering, guys? Soldering, in the sense, it's a mechanical terminology where you try to, it is a chip terminology, okay, where you try to fill in the, when you're connecting two different wires in electronics, you do it very carefully, right? So that part, in that part, when you're doing such a soldering, there's a quality aspect that there's a quality team that will look at the PCB board and test the connections, whether it is perfectly all right or not. Okay. So at that part, what I can do as an AI, if I am an AI guy and I was called in to improvise this particular area, okay, what I can do is, using computer vision, I can take picture of each I can take a picture of each board that is coming into the quality area. Okay, after taking the picture, I can have a golden template. In the sense, in the golden template, we'll have 100% nice connections done. Okay, so I can compare this image with that image and make out how well the new PCB was manufactured. Okay, so here you are using something called computer vision and you are determining the quality of the newly made PCB board. So that's how your data science is being implemented in a real-time industries. Okay. So here, what is needed? You need domain expertise, right? What is domain expertise is all about in the sense when you are working on a certain kind of data. So here I am working upon a image data which is having the soldering technology. Okay, which is having that. Mechanical and electronics technology which had involved the science of mechanics and ECA technology. So such understanding I should have as a data scientist when I'm working on such a data. Okay, so what does they mean by having hacker mindset in the sense? Hacker mindset in the sense to tap into the data sources. I mean, we should be ethically taking the data such a way that it will help me to train my ML models, right? So I'll come to how training works and stuff, but that is the mindset one should have. And visualization. Now tell me, if I give you an Excel sheet of 10,000 rows, will you be able to tell me how the trend is, whether it is having an incremental trend or a decremental trend, how the data is varying? Can you and I tell it, guys? Can we say, okay, this is incremental in nature, this is decremental in nature? Can we say that by just by looking at the raw data? No.
No, we cannot.
We cannot say to such a huge data. In such a case, we need to do visualization. So your visualization is nothing but something like reporting part, which your data engineer will do. But some companies may not have a data engineer. So as a data scientist, you should have the capability to do something called EDA, guys, exploratory data analysis, right? So exploratory data analysis is nothing but what a data analyst will do. A data analyst will, try to bring out what is there in the existing data, right? That's what your visualization part will do. It will try to tell us how well the data, whether it is incremental manner or in a decremental manner, that way. Okay. Coming to statistics and okay, these three parts on your right side: mathematics, statistics, and advanced computing, right? So your mathematics is pretty much important in your data science field because you have hell a lot of algorithms. You have so many algorithms, you have so many AI techniques. But if you don't know what to use when, then will it, you will cause a damage to your company because you will have a lot of data. You will try implementing, you can't use trial and error method, isn't it? You can't start using logistic regression, SVM, and all these, models one by one and understand, okay, that particular model is giving me accuracy, so I'll go through that. So that cannot be the case when you're working for a company, right? You should be cost effective. You should reduce the cost of the company. So mathematics behind each machine learning algorithm will help you to choose what is what, right? So, okay, I am getting a question called, can classifiers be used? So what is classification? Basically, classification is nothing but you are saying whether that or this. Okay, you're trying to say, like, a business problem. Will I get a profit or not in this quarter? Is a classification problem. Okay, I will just have to say whether I'll get a profit or not. That's it. Okay, but if I go ahead and quantify the problem, saying that how much profit will I get is the question. If this is my business requirement, then it becomes a continuous problem. No matter if it is a classification problem or a continuous problem, I will have to know the mathematics behind the algorithm that I am working on, so that I'll be able to understand what's happening inside the, inside my algorithm, right? So for every kind of data, all your machine learning algorithms will not work. Some might respond, some might not respond. Why they don't respond is because the mathematics involved in such algorithms will not work for the kind of data you are using. So what I'm trying to arrive at is, guys, understand this statement carefully. I need to have a thorough understanding on the business problem when I am going to attempt a problem. Okay, when I am trying to say that I am ready to solve a problem, I should have a complete understanding on the business requirement or the problem statement or the objective. Okay, these three are the same things. Okay, they use different stuff. Okay, so Yeah. So one more thing is to have in mind is that we need to make sure that our data, how the data is, by looking at the kind of data that we have, whether it is fetching us in a structured manner or in an unstructured manner. If it is in an unstructured manner, how to deal with it, all these things we need to make sure, and then go apply the model. Your machine learning application will come only 10% of your data science world, guys. In the sense, in a day-to-day life, if I have to solve a problem, 10% of my time goes into applying the model, but my 60% goes in cleaning the data, doing some feature engineering on top of the data, and trying to get the insights. So essentially, as a data guy, you should be knowing everything what's happening in data science, data engineering, and business intelligence, so as to become a thorough person. So generally, working with the data in a business will be something like this. You will have an operational database, or else you'll be storing data in a certain memory, right? So this is your operational database. From these different sources, you try to build a atomic database or a single database, and from that database you try to transform the data and give it to individual business users, like your managers or someone who wants the insights. Okay, so that's how a data guy should be. He should be having everything in hand, right? I mean, he should be knowing the programming part. He should he should be knowing the mathematical aspect, right? Okay, someone is asking a question: can machine vision works here, like segmentation, etc., instead of ML? So it's like this. It depends on, again, the objective. If it is an image classification, I can go for computer vision. Okay, so if I have huge amounts of data, I can use deep learning. Okay, I'll come to that. Give me 2 more slides, I'll come to that. Okay, so guys, for you to give us the jargons or else the technical words, there are so many stuff called big data analytics. As in, your big data is all about when you have huge amounts of unstructured data, how to deal with it is all about big data, to tell it in one sentence, right? We have cloud like Azure and AWS. We have inside big data, there's something called Spark, which helps us to process the unstructured data in a very better manner, right? So when you have time, read about big data and Spark, guys. That's very good. Okay. Now, artificial intelligence. Let's look ahead. As I said, applications of AI are everywhere, guys. You have social media, as I said, agriculture, e-commerce, entertainment, gaming, and everything. Everywhere, defense, surveillance. Everywhere you have applications of AI. What is artificial intelligence? So the data that we are getting from sensors and images, those data, we are processing it in such a way using artificial intelligence that it tells us what to do next. Okay, so if I have data of a particular machine, let's say a computer is a machine, right? So if I have an application which says, hey, which gives me a pop-up saying that, hey Anudeep, your storage is getting over, please please transfer your data to some other hard disk. So this is a minimal, I'm telling you, a small application of artificial intelligence. Basically, it suggests us what to do. That's what your artificial intelligence does. Okay, a simple machine learning pipeline looks like this, guys. When we input a raw data, first we have to pre-process that data. Once the pre-processing is done, we do machine learning. We apply machine learning algorithm on top of that. Once we have the output, we have to communicate these outputs in such a way that the actionable insights are communicated to our managers or to our business clients. Okay, so communication is also key. I thought I would go through all these, but we are only 10 minutes away to close the session. So I'm just running through the slides so that I can show the implementation part also. So in machine learning, there is something called supervised learning, as in when we already know the output, okay, and we try to predict it using machine learning algorithms. This is called supervised learning, as in you know the output already, but you try to predict it using machine learning so as to understand how well your machine learning algorithm is working. Okay, so that is how your supervised learning works, and your unsupervised learning is all about clustering techniques. Okay, wherein you don't have any idea on how it would be. Let me take an example of COVID, guys. Do we have a vaccine for COVID? If not vaccine, do we have a tablet for COVID? A medicine for COVID? No. But how researchers are working on top of that is that they are trying to understand the similarity between COVID and other diseases that are there, okay, based on the symptoms and stuff. And they are trying to group this and they are trying to find a medicine. So these type of problems are addressed by unsupervised learning. Now, reinforcement learning is something where it acts based on the feedback. So the machine learning algorithm will work on the feedback by itself and it will learn by itself without any human intervention. Okay, that is reinforcement learning in a nutshell. Okay, so I hope you all know about Netflix. You must have heard about it, and some of us might be even watching movies in that. So how it works is that from the devices and the history, browser history, it takes up the data from Kafka. This is a big data stuff. It takes the data, uses Spark for analytics, and it stores it. They have defined a recommender system. So once you start completing a movie and come out and refresh the Netflix homepage, it refreshes and says, and also gives you the percentage of how much you would be liking such movies, right? So that is how recommender system works. So this is a real-time application of ML, guys. Okay. Now someone asked me, why can't we use deep learning to certain, certain applications? Yes, deep learning needs more and more data. Let me talk about this here. So if you can see the meme, for a small amount of data like this, as small as this small pebble one, you can use traditional ML models. But when a data comes up something this big, like that, ball that you can see, the black ball that you can see, deep learning is where that comes into play. And your deep learning is all about advanced matrix calculus, guys. So you should be thorough about mathematics behind the deep learning before going into it. Okay. So your machine learning is heavily being used in Google. Okay. And this is how, there are architectures called convolutional neural networks and recurrent neural networks, which, which are different for different applications. So on your left side, your CNNs are used for image classification type of problems. Right side, RNNs are used for your text classification. So NLP or else text classification you do, right? For the, your when you're typing a message, you'll get predictions, right? Word predictions. So that is nothing but your RNN. So guys, tell me, what is neural networks? Neural networks it's nothing but your mimicking of your brain, guys. So there are so many applications of neural networks and computer vision. Image captioning, you can do. You can, when you input image as the image as an input to your CNN, it gives the output like this: 2 pizzas sitting on top of a stove oven. Okay, how these are useful when I am running a huge media and I'm getting so many news. I can't sit writing the captions, right? So I can use deep learning. Okay, let me take up another good. Let me share my complete screen. Can you see my screen, guys?
Yeah.
Okay, just a second. Let me include the audio also. Share computer sound. Yes, share. Give me a moment, guys. I have a couple of YouTube videos to show you. So this is the face recognition system down in VIT University, guys. Can you see? It's more of a video analytics.
Yeah, we can see.
So this is facial recognition application. This is using computer vision, guys. I just want to show you one more. I hope you can hear the audio also, people.
This year I figured we could do something a little bit different. And instead of me telling you how great this class is, I figured we could invite someone else from outside the class to do that instead. So let's check this out first.
Hi, everybody, and welcome to MIT 6S191, the official introductory course on deep learning taught here at MIT. Deep learning is revolutionizing so many fields, from robotics to medicine and everything in between. You'll learn the fundamentals of this field and how you can build some of these incredible algorithms. In fact, this entire speech and video are not real and were created using deep learning and artificial intelligence. And in this class, you'll learn how. It has been an honor to speak with you today, and I hope you enjoy the course.
Right. Hi, everybody, and welcome to MIT 6S191.
Hi, everybody, and welcome to MIT 6S191, the official introductory course on deep learning taught here at MIT.
Okay. Okay. How was it, guys? You know, Obama did not speak all those words. It was actually generated by a deep learning algorithm. Will you believe that?
Yeah, it was really amazing.
So one thing that at the start of the session, someone had asked me to take to the implementation, guys. If you can give me 2 more minutes, I'll just quickly show you the implementation of image classification. Are we okay for that, Sabi? Vikram?
Yeah, sure.
Yeah, just 2 more minutes, guys. 2 more minutes. Bear with me. So I have data something like this, guys, as you can see. Okay. So basically, what I have a e-commerce data. Okay. Could you share the link? It's in my local, Amar. I can share you something from Kaggle. Will that be fair enough, Amar? Will that be fair enough? Yeah, I'll share it for something from Kaggle, okay? But let me take you through quickly on how things work. Fair enough? So I have an e-commerce data which has images of t-shirts, trousers, a dress, coat, sandal, and stuff. Okay. So how does the data looks like? Looks like this, guys. Like something like a heat map. Okay, something like a heat map. Now, what we are doing is that we are taking the data into like this from the data set. We are taking into X test and Y test. Okay, if you don't know Python also, don't worry. I'm just showing you this one. You can always learn Python. That's very easy, not a big deal. So data pre-processing, what we are doing is that, as I said, guys, in supervised learning, we have to, take out the Y aspect. Y aspect in the sense, my Y is called the target aspect. We already know what is what. So if you see, when I print this, the label is 9, which means this is a shoe. Label 9 is ankle boot. Okay, so I have the data, but what I'm doing, I am trying to keep it as a test data. We need to train and test the data. Okay, so I from the Keras library, okay, we are importing certain optimizers, activation functions, and necessary libraries, and we are defining the model. I mean, should I wait a second? Let me show you an neural network view. No. Okay. So we are defining the layers inside a neural network. Okay, let me show you if I have any neural network. No. Okay. So my input layer, since the kind of data I have is 28 by 28 pixels, which means it's 28 height and 28 width, guys. See, if you see, it's 28. Those all the inputs with 50 units. I am defining the units as 50. Okay, I am telling the model is a sequential model. Like if you can see my screen, I mean, I'll draw it for you. So it looks something like so it's look something like this. My input neurons, and then hidden layers, and then output. Okay. My output will be 1 because it's classification problem. So my hidden layers can be like this. So it's like your data is coming from each neuron. So you are inputting to this particular input neural network, then it will pass through the hidden layers and it will finally go to the output. I'll show you one from the Google, that should be fine. Neural. So if you can see, your neural network looks something like this, guys. Right? So we have to define each layer. We have to define input layer, next hidden layer, next another hidden layer, and finally output layer. Any layer between input layer and output layer is called a hidden layer, guys. Okay. So here we are using something called activation function called sigmoid. So what is an activation function? How are we thinking to the brain? If we go back to biology, right? Our neurons work with an electrical impulse. So the electrical impulse in this is sigmoid function. So this is called activation function. So generally these are non-linear mathematical functions, guys. So here the impulse is given by non-linear mathematical functions. Okay. So I had defined 50 units of input layer, next 50 units of hidden layer 1, hidden layer 2, hidden layer 3, and finally my output layer with the activation function as softmax. So why did we use softmax here is because since I want a classification, the activation function should be somewhere between I want 10 types of classes, isn't it? So if I show you the data, it's from 0 to 9, which means 10 types of classes are there. So I want it between, I want to do a multi-classification. So this particular softmax function allows me to do multi-classification. So it can give me an output of 10 classes, right? So I am defining the optimizers. Here they have defined stochastic gradient descent with a learning rate of 0.01. So you can also use Adam. Okay. So initially they have used softmax function, and they had tried. They had defined a loss function as categorical cross entropy function, and they want accuracy to be. They want the metric that whether the model is working fine or not. They want the metric to be accuracy. So on the training data for 100 epochs, okay, with batch size 200, the output is 78%, which is very low. And on my test accuracy is 77%, which means we are comparing the labels and also, I mean, the labels in the sense the data which already we have and the predicted data, when we compare, the accuracy is only 77%, which is very less. Okay, so how we can improvise this model is by changing the activation function. Here we have used ReLU function, okay, in the same model, and we tried to see the accuracy. The test accuracy has come to 84%. So it improved, right? So that's how we implement. So there are certain optimization techniques. You know, it takes a lot of time to explain them. So there are many optimization techniques using which you can improve the test accuracy. Okay, so that's how you do the deep learning model, guys. That's how you model out this particular image, by defining it by using Keras. Okay, I know you can't understand it in one go, but did you get a fair idea on how things happen, how implementation happens? Especially Amar, who had asked this, did you get a fair idea, Amar? Okay. Yes, so in the Kaggle.com, guys, let me sign into my account. So in the Kaggle, you will have so many notebooks with implementations. So you can consider looking into different notebooks. So I can say image classification using ANN. So like this, I can search. So see, this is one intro to Keras. Okay, so they have given introduction in a very good way. So you can go through this link, guys. You can see the implementation. Okay, so I have taken extra 10 minutes. I'm sorry, guys, but you know, since Amar had asked, I had to go through this. Yes, that's the link. I hope everyone can access that. Not only that, you can see all the many Kaggle implementations. If you want to look at Titanic, so you can see Titanic dataset. If you are very much new to data science, you can look at Titanic dataset. Let me give you the finest notebook. Okay. So this is introduction to Titanic dataset. Yeah, this way you can see some introduction kind of files, how to deal with the data, such stuff you can see here, guys. So likewise, you can search for Kaggle notebooks and see, guys. So that's how you learn. Okay, so any questions, guys, from anyone? I would love to talk more, but we have we have planned session only for 1 hour, right? So yeah, this much is what I could share with you guys. Any questions, anyone?
Any questions, anyone? So I guess we should close the session, Anudeep.
Yeah.
We got one question. So if you
Any
can quickly answer
guidance
that.
about? Yes, how to start? Okay, so one thing is you have to do things parallelly, guys. You have to learn Python programming on one hand, and on the other hand, you should learn the basic concepts of ML algorithms on the other hand. And Kaggle can help you to learn how to implement. So these are the three things that you have to keep in mind: Python programming, Kaggle notebooks, and concepts, ML concepts, right? You can learn easily. Okay, and finally, once you are clear with all this, you have to learn the mathematics behind them. Basically, nobody learns the mathematics behind them, but that is what is being asked generally. So mathematics also I would suggest, but it is not compulsory. You can learn it once you start your career in data science, right? So that's what I could say. Could you please explain the ways in which a finance individual can benefit from AI? Hey, finance, when it comes to finance, there's a lot of applications, guys. So I can talk about, your credit card fraudulent aspect. You can detect the fraudulent stuff that are happening with credit card transactions, such thing I can talk about that one. And we can talk about anomaly detections, where when there is an anonymous, sometimes, a person who is using his debit card, he generally uses only 1,000 rupees in a month. Let's say, I'm just giving an example. Suddenly one fine day, a 10,000 rupees or a 1 lakh rupee transaction happens. That's an anomaly, right? So those anomaly detections can happen. So in banks, in other financial institutions, there's a lot of usage of AI and blockchain technology and stuff. There's lots of stuff that has to be done. I have told only two things on my mind, but I would suggest you to Google. So Google can give you so many applications. Yeah. Yes.
Okay.
No problem.
Okay, so now I would like to close this session. But before that, I would like to express that I feel honored by Mr. Anudeep's presence here today. He is surely an experienced resource of the AI world. And it was a great pleasure to have you here with us today, Mr. Anudeep. And I hope that you enjoyed the session too.
Yes, thoroughly. I would love to talk to people who want to know about this area. So I'm very happy that I could address you all, guys. Thanks for your time, guys. I wish and I hope that I am of some help to you guys.
Yes, definitely. Yeah. So thanks to all the attendees as well for taking out time to attend this event and for the healthy participation. I hope you are taking away a good deal of knowledge today, and I really hope to see you all in my future events as well. So thanks a lot once again. Please take care and have a nice weekend.
Yeah, take care, guys. Take care amidst pandemic. Take care of yourselves and your loved ones. Take care. Thank you. Thanks once again. Bye.
Bye, everyone.